Imagine looking up at the night sky, where distant planets orbit in their predictable paths. But one planet stands out, a world so peculiar that even the way it spins defies everything we know. Welcome to the mystery of Uranus, the giant ice planet with a secret locked in its tilted axis. Unlike any other planet in our solar system, Uranus doesn't spin upright. It rolls around the sun on its side, as if something catastrophic once knocked it over. Tonight, we embark on a journey to unravel one of the most bizarre enigmas in our cosmic neighborhood. Why is Uranus, the seventh planet from the sun, tilted 90 degrees? What cosmic event could have caused such a dramatic shift? As we explore, we'll dive deep into the theories, the science, and the unanswered questions that still baffle astronomers today. Get ready to witness a story of cosmic collisions, lost moons, and the secrets of the universe. Now, before we dive deeper into the mystery of Uranus' tilt, let's take a moment to understand this strange, distant world. Uranus is a giant, but not like the gas titans Jupiter or Saturn. It belongs to a unique class, an ice giant, made mostly of icy water, methane, and ammonia swirling around a small rocky core. This planet is a frigid, distant gem. It's so far from the sun that sunlight takes over 2.5 hours to reach it. Temperatures here can plummet to 224 degrees Celsius, making it the coldest planet in our solar system. But there's more. Uranus is a pale blue ball, thanks to the methane in its atmosphere, which absorbs red light and scatters blue. This planet is massive, 4 times the size of Earth, but its density is surprisingly low, second only to Saturn. Imagine floating above its cloud tops, watching the pale blues blend into hazy mists. From its distance, the sun is just a bright star in the sky. Uranus is mysterious, silent, and as we'll soon learn, full of secrets waiting to be uncovered. Now let's turn to what truly makes Uranus one of the most unusual planets in our solar system: its bizarre tilt. Imagine a spinning top, balanced on its tip as it twirls. This is how most planets spin, with their axes tilted just slightly. Earth, for example, has a tilt of 23.5 degrees, giving us our seasons. But Uranus? It's like a top that has fallen on its side. Its axis is tilted a staggering 98 degrees, almost lying flat as it moves around the sun. This means that, for long stretches of time, one pole is pointed directly at the sun, while the other is in complete darkness, creating extreme and strange seasons that last decades. Picture this: if you were standing on Uranus, you'd experience 21 years of daylight, followed by 21 years of darkness. How did this happen? What could possibly cause a planet to tumble over like this? It's a question that's puzzled scientists for centuries, and the answers lie in a tale of cosmic violence and mysterious forces at play. As we journey through the solar system, it's clear that Uranus stands apart. Most planets, like Earth, Mars, or even its icy neighbor Neptune, spin with a slight tilt, something close to vertical. Neptune, for instance, tilts at just 28 degrees, but compared to Uranus's extreme 98-degree tilt, it feels almost ordinary. This stark contrast raises even more questions. Why did Uranus experience such a dramatic shift while other planets didn't? Is it simply a matter of chance, or is there something more hidden in the early chaos of the solar system? What's certain is that this difference makes Uranus a unique cosmic puzzle, one that continues to baffle scientists to this day. But the deeper we look, the more incredible the mystery becomes. Curious about more cosmic mysteries? Subscribe now and stay on this journey of discovery. Now let's dive into the effect this dramatic tilt has on Uranus' climate. Picture a planet where the poles, not the equator, get the most sunlight. Due to its extreme tilt, Uranus has seasons unlike any other planet. For nearly half of its 84-year orbit, one pole basks in constant sunlight while the other is in complete darkness. Imagine standing at a pole, watching the sun circle the sky without setting for 21 years, followed by 21 years of night. The equator barely sees sunlight during these times, creating a climate where the poles are warmer than the midsection. This orientation also generates massive weather systems, stormy bands, and freezing winds. It's a world where day and night are stretched in ways we can barely comprehend. Understanding this chaotic climate unlocks more about Uranus and the forces that shaped it. Now, let's dive into the most popular theory behind Uranus's extreme tilt, a theory that involves unimaginable cosmic violence. Scientists believe that long ago, Uranus may have experienced a catastrophic collision with a massive object, perhaps the size of Earth. Imagine a planet wandering through the early solar system, crashing into Uranus with such force that it knocked the planet onto its side. The remnants of this collision, lost in time, but the evidence remains in Uranus's bizarre orientation. This theory is compelling because it explains not only the tilt, but also some of the planet's other oddities, like its chaotic moons and unusual rotation. It's as if this collision changed the course of Uranus's entire history. But while this hypothesis is the most accepted, it's not without its challenges. Could there be other forces at play? What else shaped this mysterious world? The story of Uranus is far from over, and the search for answers continues. The idea of a colossal collision is fascinating, but how do we actually know it happened? Scientists have turned to advanced simulations and computer models to test this theory. These models show that a massive impact could indeed explain Uranus's 98-degree tilt. Imagine watching the solar system billions of years ago, chaotic and violent, with planets forming and colliding. In this chaos, one fateful impact sent Uranus spinning sideways, forever altering its destiny. Simulations also suggest that such a collision could have created Uranus' unusual system of moons and rings. These moons, irregularly shaped and orbiting at strange angles, are like clues left behind by the impact, hinting at the event that changed everything. It's a cosmic detective story, with every piece of evidence pointing toward a moment of unimaginable destruction. But while these simulations are convincing, they don't answer every question question. There's still more to uncover about the forces that shaped Uranus into the tilted giant we see today. While the collision theory dominates, it's not the only explanation for Uranus' strange tilt. Some scientists believe there could be another, equally fascinating reason: a missing moon. Picture this: in the early days of the solar system, Uranus might have had a large satellite, similar to Neptune's moon Triton. Over millions of years, gravitational forces between the moon and Uranus may have caused a slow, gradual shift, tilting the planet bit by bit. Then, at some point, this primordial moon could have drifted away or been ejected from the system entirely, leaving Uranus permanently tilted. It's a wild idea, but not impossible. The absence of this moon leaves a gap in the story, a piece of the puzzle that could change our entire understanding of Uranus's history. Theories like this remind us how little we still know about the early solar system, a time of chaos, collisions, and missing worlds. But what about the moons that Uranus still has? Could they hold the key to this cosmic mystery? Uranus has 27 known moons, each orbiting in unique, tilted paths. These moons, unlike those of most planets, don't follow the equator. They're caught in strange, skewed orbits, mirroring the odd angle of the planet itself. It's as if they too were affected by whatever event tilted Uranus. Some of these moons are tiny, barely more than chunks of ice and rock, while others are larger, like Miranda, with a surface that looks like it's been shattered and pieced back together. These moons might hold clues to the planet's past, offering us a glimpse into the forces that shaped Uranus. Did they form after the tilt, or were they there before, witnesses to the dramatic event that forever changed their world? Each moon is like a time capsule, frozen in its strange orbit, waiting to reveal the secrets of the early solar system. Studying them could be the next step towards solving the enigma of Uranus. As if Uranus's tilt wasn't strange enough, its magnetic field adds another layer of mystery. Unlike Earth, where the magnetic field is closely aligned with the planet's axis of rotation, Uranus's magnetic field is wildly off-center. It's tilted by about 60 degrees from the rotational axis and isn't even located at the planet's core. It seems to be offset, as if the entire magnetic field was shifted to one side. Imagine a magnet that doesn't sit at the center of the planet, but somewhere off to the side, creating a lopsided and chaotic magnetic bubble around Uranus. This means that the magnetic field behaves unpredictably, wobbling as the planet rotates. The result? Unusual shifting patterns of radiation and magnetism that would make navigating through Uranus' atmosphere incredibly challenging. Scientists are still trying to figure out why the field is so misaligned. Was it affected by the same event that tilted the planet, or is there another force at work? It's another puzzle that makes Uranus one of the most fascinating and perplexing planets in the solar system. Now, let's compare Uranus's magnetic field with those of other planets. Earth's magnetic field, for example, is aligned with its rotational axis, protecting us from solar radiation and creating the beautiful auroras we see near the poles. Jupiter and Saturn have similarly strong, organized magnetic fields. Even Neptune, Uranus's icy neighbor, has a magnetic field that's more aligned, though still somewhat tilted. But Uranus, its magnetic field is wildly chaotic. It's not only tilted at 60 degrees, but also offset from the planet's center, creating a complex, constantly shifting environment. This misalignment causes strange magnetic interactions as Uranus rotates, unlike anything seen on other planets. What could have caused such an unusual magnetic field, and why is it so different from the other giants in the solar system? The more we study it, the more questions arise, adding to the enigma of this distant world. As we dig deeper into Uranus's mysteries, we begin to wonder, what does this tell us about the early days of the solar system? Could Uranus' strange tilt and magnetic field be a relic of those chaotic times? Billions of years ago, the solar system was a violent place, with planets forming, colliding, and shifting. Uranus' tilt could be a direct result of this ancient chaos, offering us a rare glimpse into the solar system's turbulent beginnings. Theories suggest that during this time, massive impacts and gravitational forces shaped the planets in ways we're only now beginning to understand. Uranus, with its extreme tilt and chaotic magnetic field, might be a unique window into that early era, a time when the forces of nature were wild and unpredictable. Understanding how Uranus was shaped could help us unlock the secrets of planetary formation across the entire universe. Now imagine the early solar system, a chaotic arena of collisions where planets were bombarded by massive objects, shaping them into what we see today. Uranus wasn't alone in experiencing these violent impacts. In fact, many of the planets we know today bear the scars of this cosmic warfare. The craters on Mercury and the Moon, the tilted axis of Venus, each is a clue to the violent past of our planetary neighborhood. In this arena of collisions, Uranus may have been struck by a colossal object, flipping it onto its side and forever altering its destiny. But it wasn't the only planet to face such a fate. These impacts played a crucial role in the evolution of planets, dictating their tilt, rotation, and even the formation of their moons. Uranus stands as one of the most extreme examples of this ancient violence, a planet forever changed by forces that shaped our entire solar system. To better understand what happened to Uranus, scientists have turned to powerful tools, simulations, and computer models. Imagine a virtual version of the solar system, where planets and moons collide, shift, and form, all under the watchful eye of advanced technology. These simulations allow us to recreate the early solar system, testing different theories about how Uranus ended up so drastically tilted. Through these models, we can explore scenarios where Uranus was struck by an Earth-sized object, or where gravitational forces from nearby planets planets tugged it into its current position. Each simulation brings us closer to the truth, offering glimpses of what might have happened billions of years ago. But despite the power of these tools, the exact details remain elusive, leaving us with a fascinating puzzle that's still far from being completely solved. The story of Uranus isn't just about one planet. It has far-reaching implications for how we understand the formation of all planets, especially the giant ones. By studying Uranus, we gain insights into the forces that shaped Jupiter, Saturn, and even distant exoplanets beyond our solar system. Could similar collisions or gravitational shifts have occurred elsewhere in the universe? The extreme tilt of Uranus challenges our understanding of planetary formation and evolution. It suggests that the early solar system was far more chaotic and unpredictable than we once believed. If Uranus can be knocked sideways, what other mysteries might be hidden in the orbits of distant planets and stars? Every new piece of data brings us closer to unraveling not just the secrets of Uranus, but the story of how worlds are born and shaped throughout the cosmos. As we continue to explore the mysteries of Uranus, one thing becomes clear: we need more data, and that means sending a mission to this distant world. Unlike Jupiter or Saturn, which have been visited by several spacecraft, Uranus has only been briefly glanced at by Voyager 2 back in 1986. That flyby gave us a tantalizing glimpse, but it's not enough. To truly understand this mysterious planet, we need a dedicated mission, a spacecraft designed to orbit Uranus, study its atmosphere, its moons, its rings, and of course its tilted axis. Such a mission could unlock answers to questions that have baffled scientists for decades. It could reveal what caused the tilt, how its magnetic field works, and whether there are oceans hidden beneath the icy surfaces of its moons. With the right tools and technology, we could uncover secrets that would not only change what we know about Uranus, but about planetary systems across the galaxy. The journey to unravel these mysteries is only just beginning. Imagine a future where a spacecraft is launched, its destination set for Uranus, a place that's been waiting, untouched, for decades. This mission would be one of the most ambitious ever undertaken, traveling over 2 billion kilometers to study a planet that has intrigued scientists since its discovery. Equipped with advanced instruments, this spacecraft could orbit Uranus, mapping its atmosphere, probing its magnetic field, and taking detailed images of its moons and rings. Such a mission would be a game changer, allowing us to explore Uranus up close for the first time. It could confirm or challenge the theories we've developed. Was it a massive collision that knocked Uranus on its side, or is there another explanation waiting to be uncovered? We could even discover new, unexpected phenomena. Every corner of Uranus holds potential for discovery, and with the right mission, we might not only solve the mystery of its tilt, but also uncover new wonders that could reshape our understanding of the outer solar system. As we look beyond Uranus, it's important to remember that this planet isn't just an isolated oddity. It's part of a family of gas and ice giants that includes Jupiter, Saturn, and Neptune. Each of these planets has its own unique traits, but Uranus stands out because of its extreme tilt. By comparing Uranus with its fellow giants, we start to see how different and mysterious this planet truly is. Jupiter and Saturn, with their massive sizes and powerful magnetic fields, are giants of a different kind. They spin quickly, with magnetic fields closely aligned to their axes. Neptune, Uranus' icy neighbor, shares some similarities with its tilt and atmosphere, but still doesn't exhibit the same bizarre characteristics. Understanding why Uranus is so different could reveal the hidden dynamics of how these massive planets formed and evolved. It's like piecing together a cosmic puzzle, and each planet adds a crucial piece to the story. As we dive deeper into Uranus's mysteries, one thing becomes abundantly clear: there's still so much we don't know. Despite decades of study, we're left with more questions than answers. What exactly caused its extreme tilt? How did its magnetic field become so misaligned? And could there be hidden oceans beneath the icy surfaces of its moons, waiting to be discovered? These are just a few of the puzzles that Uranus presents. While some theories have gained traction, no single explanation fully satisfies all the strange characteristics of this planet. It's a reminder that, even with all our technological advances, the outer reaches of the solar system still hold deep mysteries. Every piece of data we gather is like another clue, slowly bringing us closer to the truth. But there's still so much left unexplored. Uranus remains one of the most enigmatic planets in our solar system, and its secrets are waiting to be uncovered. As we come to the end of this journey through the mysteries of Uranus, we're left with a sense of awe. This distant ice giant, with its tilted axis, chaotic magnetic field, and moons shrouded in mystery, continues to challenge our understanding of the cosmos. Yet, the story of Uranus is far from over. In fact, it's just beginning. Future missions, advanced simulations, and new discoveries will bring us closer to uncovering the truth about this enigmatic planet. The more we learn, the more we realize how much is still hidden beneath its icy atmosphere and strange seasons. Uranus is not just a planet, it's a cosmic puzzle, one that holds answers to questions about planetary formation, the early solar system, and perhaps even life itself. As we gaze up at the night sky, we know that the next chapter in the story of Uranus is waiting to be written, and it will be one filled with wonder, discovery, and the thrill of exploration.